Thank you everyone for joining the webinar. My name is Tasos Mikhail. I'm a senior product manager with the Prisma SD-WAN team at Palo Alto Networks. And today we'll be giving you a presentation on policy model and benefits. And we will go over some specific use cases and examples of how you build different policies and apply them to branch and data center sites. So the one thing is I want to mention that we will actually be taking questions from the chat window, but we will also have some time at the end of the presentation if anybody wants to ask any questions live. So I'm going to start by giving a quick introduction on the policy model and its benefits for the Prisma SD-WAN solution. And the first thing I want to go over is the configuration abstraction. The goal of the Prisma SD-WAN design is to be able to provide a level of configuration abstraction that allows you to create a given configuration element once and then use it at scale across the enterprise and across your network. With Prisma SD-WAN, the configuration is abstracted to a global or a site-based level without having a device. This can be done by using multiple policy modules, application definitions, and prefix filters. And think of these modules as interchangeable building blocks that you can reuse across policy sets throughout an enterprise, which would help you simplify the configuration and the operational tasks compared to other methods that are seen by other products. We actually, by leveraging this model, you can pretty much abstract 90% of the configuration away from the device, which means that you can go ahead and implement certain policy rules and build your configs at a logical site level without really having the device claimed and activated. And you can then complete your tasks and finalize your configuration, the remaining 10% after the device has been activated in the cloud controller, in your tenant. Some of the elements that can be pre-configured are path policy, QoS policy, security policy, and zone-based firewall rules, NAT policy, application definitions, and prefix filters. And we're going to be going over those in more detail in the upcoming slides. Now, by actually having a centralized policy configuration and control, you can actually define specific policies for branch sites and for different data center sites. By default, each branch site must have an assigned policy for path, NAT, and QoS. And optionally, you can also apply a security policy set. The system by default has pre-configured default policies that are provided, and those would be applied to branch sites from the controller. But the admin has the ability to go and build custom policies, and you can have site-specific policies, right? So for let's say a given branch site type, you can have an certain set of policies, and then for a different type of branch site, you can have another set of policies, and you have the ability to actually clone those and customize them and edit them to fit your business needs. And then the other thing is the Prisma SD-WAN is actually will differentiate, has the ability to you have the ability to build the rules based on different parameters. So that way you can differentiate between, for example, cloud-based apps or enterprise-hosted apps. So we're going to go over some of these examples in the upcoming sections. Another benefit actually of this configuration model is that you can actually also create domains within the system, and domains can actually represent logical groupings or geographical groupings. So that way you can actually have a set of branches and data center data center groups based on your business requirements. In this particular example, we're showing grouping based on regions or geographies. So you can have like a North America domain, EMEA, APAC, and China domain, and then you can apply different policy sets, different policy rules for sites that belong to these domains. So this gives you the flexibility to, essentially create some geofencing and, keep the configurations or the rules different from one region to another. Now, all these benefits that come with the way you can actually have these policy building blocks leverage the fundamental ability of Prisma SD-WAN to be like an app-defined solution, right? So one of the foundational elements within Prisma SD-WAN is that essentially it is a routing and policy, an application routing and policy engine, right? So it is very fundamental in the system to be able to understand applications and be able to identify applications so that it can actually select the right path for forwarding flows. So at a high level, Prisma SD-WAN uses two types of application definitions. We have system applications that are defined, managed, and maintained by the SD-WAN software, and those are preloaded and automatically updated every time we actually release a new version of our software. And then you have custom applications. So custom applications are unique to your enterprise, and you can actually define them through the user interface in the cloud controller. And they can be defined based on layer 3, layer 4, or layer 7 match criteria. So, and then the way the system works is that actually it does support a very sophisticated app detection mechanism, which relies on multiple methods for app detection. We're using things like static application ports, URLs, protocol signatures, transport layer, and other layer 3, layer 4, or layer 7 fields to identify applications, and then be able to use that information to apply policies and enforce policies based on the rules that you define. One of the key areas where we've actually, with our most recent release, 6.0, we've extended the support is the unified app ID capability. So, so far, Prisma SD-WAN was supporting, hundreds of app IDs built in as part of the original like CloudGenix implementation. And with release 6.0, we've actually extended that application ID set to provide application detection services for a higher number of applications, and also unified the set to be common across PAN-OS and Prisma Access. So the unified app ID support gives you a broader set of app definitions in the system, but also give you like a essentially leverages the Palo Alto Networks app ID engine, which is common across multiple products. So it gives you actually more flexibility, in your roadmap towards like a unified SASE solution to basically have a common app ID engine across different parts of the product. So with that, I'm going to hand it over to Richard, who's going to go over some of the details about policy. So let me stop sharing here.
Thanks, Douglas. Just get ready. Okay, yeah, hey everybody. So I'm Richard Gallagher, Senior Technical Marketing Engineer for the Prisma SASE team, and we're going to go into a little bit more detail about policies and use cases for them. Okay, so we're going to just review first the different types of policies that we have in the Prisma SD-WAN solution. So as Tazos already indicated, so a Prisma SD-WAN branch site, it can utilize 4 of the main types of policies that we have in the solution. So each site has a mandatory path policy, QS policy, and NAT policy. So when you onboard a Prisma SD-WAN site, as you go through the onboarding process, at some point you have to pick the policies for the site, and you must configure a pass policy, you must configure a QoS policy, and you must configure a NAT policy. If you want to configure security policies as well, these are optional, but we do recommend that security policies are implemented. And for every new Prisma SD-WAN customer that we have, we build a set of default policies for them out of the box. So there are a path, a QoS, and a NAT policy that is automatically created when a new tenant is onboarded, which have some basic rules in them, which allow you to get a head start on your policies. But then, you can tailor those to your specific business requirements. So, the policies should be configured to meet the business intent of your enterprise. Okay, so we're going to review each policy type, the policy set and rule kind of characteristics. So a path policy set, it has a number of rules in it. It will have 2 default rules, and then it will have additional custom rules that you can configure on top of this. So these rules have a specific set of match criteria, and this match criteria will then have an action, and the action will be to set the allowed paths and DC and service groups for that particular traffic. So the paths can be active-active, they can be active backup, and then we also have L3 failure path. So this is common for when we want to implement LTE services at a site. We may only want our LTE service to be used if the primary circuits are down. So if we have a DIA circuit and a LTE circuit, we may only want the L3 failure path or the LTE circuit to be used if the primary is down. So we have full flexibility in our policy definition, and we'll go through some examples later showing this L3 failure case. And DC and service groups, we'll go into a bit more detail on them later on, but these allow us to set either SD-WAN data centers or third-party services to be transit points for our traffic. So from a match criteria for a policy set, we have the order of the rule. So there is a numbered ordering, and we'll get into ordering a bit later. There's a network context, which is used to signify whether a particular port is within a certain group. It simplifies the matching of traffic. Rather than having to match on an IP address, we can just say that this port here is a guest port, and any traffic that comes in the guest port will have guest policy applied to it. We also match on source and destination prefix. We can match on the app ID, and then the mix of these different match criteria will allow us to set a path and a service and DC transit option for that particular traffic. So for QoS and policy sets and rules, so QoS policy set, again, it has 1 or more rules with specific match criteria. These are going to be very similar match criteria to the path policies. So we have an order, a context, source and destination prefix, applications, but the action is different for a QoS policy. So we have 4 main QoS buckets, let's say, that we can put the traffic into. So we have a platinum, gold, silver, and bronze. And then based on the QoS priority that we're given, the traffic will be given the appropriate priority. And within each of these main platinum, gold, silver, and bronze groups, we have subgroups for different types of traffic. So we can give different priority to real-time traffic or bulk traffic within each of those priority groups. And from a DSCP marking perspective, when traffic comes into the branch device and policy is applied to it, any DSCP markings that are on the traffic that comes from the user or from the application are automatically copied over to the outbound traffic when it goes out to the internet, to Prisma Access, to SD-WAN data center. In the QoS policy construct, we do have an option where you can remark your traffic. So if traffic comes in with specific marking and we want to mark it to something else, you have the option to do that as well. So moving on to NAT policy sets and rules, similar kind of situation as the previous ones. We have a number of match criteria, and then we can apply NAT policy on them. So we've tried to kind of change a little way how NAT is done. We don't typically have this inside-outside that you would have with a normal NAT situation. We're a fully zone-based NAT solution. So every internet port is automatically applied an internet zone. This is done automatically when you assign an internet label to an internet port. It automatically gets assigned the internet zone for it. And by default, any traffic that is going from the LAN side out to the internet, that is egressing through this internet labeled port, will have an internet source NAT rule applied to it. So this means that outside the box, out of the box, straight from the configuration, you don't actually have to implement any NAT in order for your LAN traffic to get out to the internet via DIA. This will automatically be configured because you have to apply a mandatory NAT policy to the site. This means that this policy will already be in place, so you don't have to worry about configuring NAT unless you have some specific NAT requirements that you need to add. Okay, so security policy sets and rules. Again, security policy is implemented through our layer 7 zone-based firewall. It is not mandatory. You can have a site without a security policy, but we do recommend that you implement security policies. And it's a zone-based firewall, meaning that interfaces can be assigned to different zones. Interfaces can be in their own unique zone. They can only be in one zone, but you can have multiple interfaces within the same zone. So you could have, 2 corporate LAN interfaces within the corporate LAN zone, and then you could have 2 guest interfaces within the guest zone. But a single LAN interface or sub-interface can only be assigned one particular zone. So the benefit of this is obviously, increasing the security on your branch devices. So it gives us the flexibility to isolate networks. So if I don't want my guest traffic to be able to access my corporate LAN zone, then I would have policy in place to ensure that the traffic is not allowed between those 2 zones. So, it needs to reflect your security enforcement intent. So whatever security desires you have for your organization, we can implement those through the zone-based firewall. So a security policy set has some default rules in them. The other policies all have some default rules. The security policy has some slightly different rules. So there are 3 rules in a default security policy set that are pre-built into the system. So there's a self zone, which is traffic that's generated to or from the ION. This is permitted. And there's an intrazone rule. So this means that any traffic that's going between 2 interfaces that are within the same zone is permitted. So if we have 2 corporate LAN interfaces within the same corporate LAN zone, then traffic is permitted between these 2. Very similar to how a PAN-OS firewall would work as well. And then after that, there's a default denial. So with a path policy, we have some inbuilt policies which you can apply to a site, which will allow communication, but the security policy by default essentially blocks everything. So before we apply a security policy to a site, we have to make sure that we have the correct rules in place so that we are permitting the traffic that we want. Otherwise, everything will hit the denied catch-all. So the rules, like any other kind of policy set we have a numbering in them. For security policy, the numbering is kind of a much more important construct, and we'll go through that in a bit more detail. Like I said, it's a granular zone-based firewall. We typically have WAN zones and LAN zones, but it doesn't mean that we can just apply policy from WAN to LAN or the other way around. We can apply policy through LAN zones, through WAN zones. You have your full flexibility. So it supports all of the applications that we have built into the system, which Taz was alluded to, and also any custom applications that you need to support as well. So it is a stateful firewall, meaning that if you have a rule that permits traffic from your LAN to your WAN, you do not necessarily need a rule inbound for the return traffic. If you were to have DC originated traffic that's coming from the WAN into the LAN, you have to explicitly permit that. But we have a full stateful firewall. And for interzone ACLs, this means that we have different LAN segments with different zones. We can use prefix filters to more granularly permit and deny traffic between the different zones. And for each rule, there are 3 potential actions for a security policy rule. You can have a permit, obviously that allows the traffic. You can have a deny, which will essentially drop the traffic but silently. And then you can have a reject as a possible option, which will do a TCP reset for the session, so both ends know that the connection has dropped. So this is just kind of what a zone-based model may look like for a branch device. So on the top, we have the WAN zones. So we have an external zone. This may be your internet connection, so traffic that's going DIA. a VPN zone. This is a special zone within Prisma SD-WAN. Any Prisma SD-WAN tunnel, a native SD-WAN tunnel, will automatically be put into a group called VPN, and then you can apply a zone to this group of SD-WAN tunnels using the VPN construct. And then corporate in this case may be your MPLS underlay. And then for the LAN zone down here, we've got a whole different host of options. These are all fully customizable. These are not predefined. You can call them whatever you want, but we may have corporate data, corporate voice, wireless, PCI, or guest. And so, the default rule or the default behavior for any intra-zone traffic or interzone traffic is to deny. So if you want your data VLAN or data interface to be able to communicate with your voice interface, on the LAN side, you have to build specific policy that allows that traffic to communicate between the two. Okay, so we're going to talk about stacked policies. So stacked policies is the kind of modern way of policy building within Prisma SD-WAN. For any customers on the call that may have been around SD-WAN customers for a while, we had some previous policy constructs, but now stacked policies is the way that we're doing them. So all of the policies that I've talked about today, path, NAT, QoS, and security, they can all be implemented using policy stacks, and they all have their own configuration sub-screen. So we'll go through some examples showing how you actually implement them. And we have two types of stacked policies. So we have what we call a simple stacked policy, which is essentially under the covers two stacks of policies put into one simple UI to allow the easier management of the policies. So for most use cases, a simple stacked policy generally fits the bill. There are some use cases where an advanced stack policy may be usable, and we'll cover advanced stacks in a little bit. So a simple path and QoS stack. So it's a collection of policy rules in a single policy set. Under the covers, it's two policy sets, but the way that we display it to you as a user is one single policy set. So it merges the default policy rule set and then all the custom individual policy rules that you want into one set. So you can easily see them in one screen and manage your different policies. So for path and QoS, there is always two default rules. These cannot be modified, or some characteristics can be modified, but they cannot be deleted. So there is a default rule, and you can kind of think of this as your quad zero in the routing world. It is it's for traffic that doesn't match any other rules, but is destined to a public IP address. And then the enterprise default rule, this is a rule that matches out of the box for any RFC 19 address space, or any private address space that you may have, so 10.x, 172.16, and then 192.168. So any traffic that matches any of those prefixes will have the default rule applied, the enterprise default rule applied to it, unless you have a custom rule that matches something with a higher order. If you do have public address space within your enterprise, we can also modify this match criteria for the enterprise default to match any public address space that you may have in your enterprise that you're using internally. So advanced path and QoS stacks, this takes the simple stack policy and expands it out. It gives you a bit more flexibility and allows us to do some kind of more advanced features. As I said, for most customers, it's generally not needed. But it allows you to pick and choose from different policy sets that you have and apply them in a stack together. So you may have let's say a regional policy that you have for some sites, and you want an EMEA policy applied for the EMEA sites, an APAC policy applied for the APAC sites, but then you may have some global policy rules as well that you want to apply to all sites. So having this advanced stack allows you to have the flexibility of applying, let's say, regional or geo-based policies, but also global-based policies as well. So there is an ordering in the UI. We have 4 advanced stacks that you can apply, plus the default stack. And the stack on the left-hand side will always take precedence. If there's a match on the first policy stack, then that policy will be applied. If there's no matches in the first policy set, then it will move to the next one and the next one until we finally hit a match for it. And these policy rules, they can be updated on the fly. So, if you need to make a change for your APAC policy, you need to make a change in behavior for a particular type of traffic. We're just changing it at the global level. And then that policy change is then pushed down to all the devices that have that policy applied to it. So default rule policy set. So I kind of briefly touched on this, and we'll just kind of reiterate it to ensure that you understand. So there's a default rule. This matches, traffic that is destined to the internet. For the default policy sets that are configured in Prisma SD-WAN, this essentially would allow all paths. So you have a default path policy that's configured out of the box. It will allow all paths for your default rule, meaning that anything that's destined to the internet could take a DIA path, it could take a Prisma SD-WAN VPN path. And then your enterprise default rule, which is all of your traffic that matches the RFC 1918 address space. The default rule out of the box for this is to allow it on all non-public paths. So any Prisma SD-WAN VPN paths or any private WAN, let's say MPLS underlay paths. And then the default QoS rule that's provided out of the box, it has two default rules in it as well. So the same match criteria applies here. So the default rule is for your public bound traffic, your non-RFC 1918 traffic. And this is by default put into the bronze priority group. And then your enterprise default traffic, which matches your RFC 1918 address space, plus any public address space you may use internally, is by default put into the silver bucket. And then on top of that, you would build your custom QoS policy rules to match prefixes, applications, context, and then apply policy based on those match criteria. So in Prisma SD-WAN policy, and if we were specifically talking about excluding security policies here, but we have what's termed as implicit and explicit ordering. So with implicit ordering, we're essentially doing similar to the routing world where you have a longest match for a prefix. So if you have a destination IP and you have a number of different routes for it, it's going to be the longest match that is the route that the routing decision that we apply to it. So we take a similar approach here, but with policy match clauses instead. So there are different match criteria for the policy rules. So as I said, we have a network context, we have a prefix filter, we have an application, a destination prefix filter, and we'll use a combination of these to determine which rule the traffic is going to match. So essentially, the rule that has the most match criteria for the traffic that we're looking at, that rule will be applied to it if the rules all have the same ordering number. So by default, when you create a rule in the policy, it's going to create it with an ordering number of 1024. This is the kind of standard number. And if all of your rules have the same order number, then we are going to look at the matches specifically to work out which is the policy rule that we are going to apply to that particular traffic. This is what we call implicit ordering. It is also possible to use explicit ordering. So when you create your policy rules, you can build them with an order number. So as you edit the rule, and we'll see in the examples later, you can put a particular order in it. So this will affect the matching of the traffic. So if there are two rules that could potentially match the traffic that we're looking at, the one with the highest order will always win, not the longest match based on the match criteria. Okay, so service and DC groups. The service and DC groups, they allow you to map Prisma SD-WAN data centers and third-party services, typically some kind of security service, to allow your traffic or your transitory traffic to go to a specific destination. And this destination could be a Prisma SD-WAN DC, it could be a Prisma access location, could be some third-party security services that you have, and traffic from the branch that is, let's say, not going directly out to the internet, but we want it to go to a data center. In this case, let's say, we have two examples here, USDC and an EMEA DC. We can have traffic go either to those DCs on an active-active basis or an active backup. So in this example here, you may want your US branches to have their enterprise transit traffic going to the US DC, just because it's going to be closer to them. But you may want them to have a backup to the EMEA DC in case there's some problems in the US DC. And vice versa, your EMEA branch, you would probably want to have your EMEA DC as your primary SD-WAN DC, and then your US DC as a backup. Depending on how you have your DC services set up, we can also handle active-active as well. So you may have multiple DCs within the US and you want to load balance across all of them. The policy is flexible enough to support either an active or active backup. And then we can fail over between these two DCs. So if the US branch is using the US DC, but there's a problem in the US DC, it loses connectivity, the traffic will automatically fail over to the EMEA DC. And not just for like physical DC connectivity issues, let's say the internet goes down, but also application-based, SLA-based selection. So if traffic is coming from the US branch to the US DC, and that's its primary path, but based on the application SLAs, this traffic is not performing within specification, then the system will automatically move the traffic to a backup DC, and in that case, it would be to the EMEA DC. And we also do handle asymmetry. So it's possible that traffic, from your US branch may go to your US DC, but then via, some DCI solution that you have, it may be accessing an application in EMEA. This means that the traffic more than likely would come back from the EMEA DC to the branch, and we will handle this asymmetry. We will collapse the asymmetry and ensure that the traffic takes the optimum path to the application after that. And we do have an optional or mandatory transit, meaning that depending on the prefixes that are configured at the data centers, we can use kind of a longest match for the prefix to go to the DC where that prefix may live, or we may be able to force the traffic to a DC regardless of what the prefixes are that are configured at the data center sites. So here you can see an example of a service in DC group configuration in Prisma SD-WAN. You can see here the two examples in this box on the left-hand side, the two bottom examples. So you can see here we have a primary Prisma SD-WAN DC, a backup Prisma SD-WAN DC. And then for our East Coast branches, we want it to take the Reston DC, which is in Washington. And then for the West Coast branches, we want the primary to be the San Jose DC. So therefore, they're using their closest regional data center as their active data center for transit. But for the backup, we were going to flip it around. So for the East Coast branches, they would have their San Jose DC on the West Coast as their backup. And then the West Coast branches would use the Reston DC for their backup. So we allow like full failover between the two of them. And then you can see here, we have the different sites, and you can see the domain that they are attached to. So each SD-WAN site will have a domain attached to it. Here you can see the New York branch, the Raleigh branch. They are East Coast branches, meaning their primary will be the Reston DC. And then Santa Clara and Seattle are West Coast branches, meaning their primary DC will be the San Jose DC. And this is how we reference the DC groups in the policies, and we'll cover this again in the examples. But in this example here, I want all of my internet web-bound traffic to transit through my primary DC. And then if it doesn't meet the SLAs, I want it to go to the backup DC. So I have a path policy here. I'm matching applications of HTTP and SSL, so just typical internet-bound traffic. And then my path policies for this, the actions for them, or the path I want to send it to, are Prisma SD-WAN on public or Prisma SD-WAN on private, meaning it's going to take a Prisma SD-WAN tunnel to a data center. And then here I can pick the DC that I want to send it to. So the primary for the primary DC that we send it to for the East Coast branches will be one, and then the backup will be the Denver group. So when you configure these DC groups under your policy rules, you'll see we have this required flag. Essentially, this if you do not set this flag, then it will take the most direct path. So when you configure a Prisma SD-WAN data center, you can configure prefixes at this site, or you may have a branch-to-branch connection, a direct branch-to-branch tunnel. And from a forwarding perspective, the branch-to-branch tunnel would be the most optimum path. And if we leave this unchecked, then the traffic will always take the most optimum path. And in this case, it would be a site-to-site VPN between branch A and branch B. But if we have requirements for that traffic between the two branches to not go directly and to go to our DC instead, then we can use this required flag to override the kind of longest match behavior, where it will take the most direct path. So, you may have an example where you want specific traffic to go to your DC, irregardless of site to site, because you want to do some kind of inspection on it. So you may have a centralized firewall in your DC, and you want to override the behavior of the direct branch to branch. So setting this required flag means that traffic that matches this policy, but where there is a more direct path, will essentially not take the most direct path and will go to the data centers that are defined in these active and backup groups. And so for standard VPN service groups, these are for non-SD-WAN endpoints. So the most common use case that we see nowadays for Prisma SD-WAN customers is when they integrate with Prisma Access. This allows us to specify the endpoints where we want to send our Prisma Access traffic. So when a branch site is onboarded into Prisma Access, it's onboarded to a specific location. In this case here, we have a service in DC group for standard VPNs. You can see the icon color is a little different here. Orange is for Prisma SD-WAN, and this kind of teal color is for third-party services. So this allows us to send traffic, in this example for Prisma Access. You can see the active path is standard VPN on any public. So this is essentially a tunnel to Prisma Access. And then the service and DC groups here are Prisma Access all regions, which is the service and DC group here. And then in here, we have all of the different Prisma Access endpoints or locations that we can direct the traffic to. Here we have a backup where we're going to send it to a Prisma SD-WAN DC. Okay, so we're going to cover a few policy best practices. So just a few kind of like tips and tricks. I was a deployment engineer for customers for a long time for Prisma SD-WAN. So these are some kind of like tips from my customer implementations that we've done. So, the idea of the policies that we have is to try and keep things simple. So what we want to do is we want to keep the number of policy sets that we have to a minimum based on the technical requirements. So, if you have a small or even a large deployment, it may be possible just to have one or two path policies or QS policies for your whole enterprise, just depending on your requirements. So there is definitely no need to have one policy per site. That is, something we would highly recommend against. And you could have a situation where you have 100, 200 sites all with the same path policy. So, we keep the number of path policies to a minimum, and that reduces the administrative overhead for policy management. So this way we don't end up with policy set sprawl. And likewise, inside a single policy, try to keep the number of rules to a minimum that match the technical requirements that you have. So consider, building rules around, sets of applications or things that have the same match criteria. So it could be applications, prefixes, context, and then put those into the same rule. And again, this avoids policy rule sprawl, meaning you don't end up with a policy with 100 rules in it. We have some very large customers that have a path policy that may only have 3 or 4 rules in it. Because of the way that we've implemented the policy, it allows us, to be able to create these very compact, but still highly functional policy sets. If you're going to be doing prefix filters as well, we recommend you use local prefix filters. This allows you to have a prefix filter with a specific match criteria per branch. So I can have a prefix filter, let's say guest networks, but I don't need to build a prefix filter for guest network for branch A and a guest network for branch B. I can just have guest networks. And then within that prefix filter, I can say for branch A, guest networks are 10.100.0.0, and for branch 2, they are 10.101.0.0. And this way I can use this single local prefix filter within a policy rule, and it can apply to the guest segments at all of my branches based on the matches in the local prefix filter. And it's important to consider policy interactions. So, we do have different policy types, but they do all kind of play into each other. So, you have to ensure that your policies have the same or match the kind of same business intent that you have. And this particularly applies to security policies and path policies when used in conjunction. So if I have a path policy rule that says send my guest traffic to the internet, or on a direct path to the internet, but my security policy isn't in line with that, and there is not a rule in the security policy to permit traffic from guest to my direct path, then this is not going to work, because the security rule is going to block the traffic from the guest to the internet, even though the path policy tells me I should send it to the internet. So you just have to consider, when you're building path and security policy rules, that the intent of the two policy sets are in line with each other. And if you're using NAT policies as well, inbound VNAT from the internet, so let's say you have a video server on your LAN that you want to access from the internet using the public IP of the branch, you have to make sure that that you have a rule in there that allows direct on public, which means that the traffic, when it comes in from the internet, we are assessing that policy as it comes in the device from the WAN side, and we need to make sure that the path that it comes in on is allowed. So we'll have an example of that in the demo as well. And then for QoS, consider using priority buckets rather than matching the individual rules. And then for security, the specific ordering is very important. And then just for policy changes, consider what you're doing and the impact it may have, because if you have a policy applied to 100 sites and you modify one rule, then it will change behavior at 100 sites. So there's some ways to mitigate that by cloning and then using some other one. Cloning and then testing and then applying the global changes. Okay, so use cases. So this is an OS policy for use case 1. We have some Prisma SD-WAN branches and some Prisma SD-WAN data centers. There's no Prisma access in this solution. So the business requirements are that enterprise traffic should take the closest regional DC. For their enterprise traffic, they should also use their closest DC for internet-bound traffic. Guest users are to use DIA, and business and critical apps are to use 5G as a path of last resort. For QoS, media apps, highest priority. Enterprise SaaS should be given the next highest priority. General enterprise, the next, and then guest should be given the lowest priority. And for security, guest traffic should be isolated from the WAN and LAN, but local IT services must be able to reach the guest segment to manage the devices. And then we have an inbound NAT use case as well. So we're just going to switch over to the UI, and we're going to go and look at the policy sets that we've created for this particular use case. We go to policies and path. This is my path policy that we have here. My path policy, I have a few different rules. I have a guest traffic rule. So this guest traffic rule here, it matches on the guest context, which is applied to the LAN interface for the guest network. And then it has a map, it has a path as direct on primary internet. So this means send the traffic to the primary internet. So this matches the criteria that we have. If we go back to the business critical apps here, the business critical apps here, the applications that we are matching. Okay, yeah. So for business critical apps, we've defined a different path policy here. So actually, there's some apps missing here. I should have put them in. But you could define your business critical apps here that would match. And then here, I've allowed them to be Prisma SD-WAN on primary internet, but I have an L3 failure path. So this L3 failure path is for my LTE circuit. So I have specific applications that can take any path, any physical path during normal operation, but during an outage where the internet circuit is down, they are also allowed to take the 5G circuit out. But if you noted, my guest traffic was not allowed to take that path. And for the service and DC groups, I have a primary and backup here. I have Reston and San Jose for my, depending on which domain my sites are in. For my QS policy here, this is where I talked about using buckets to classify your applications. We don't need to have a specific application rule, a QS rule per application here. So I have my Platinum apps here. You can see here, these are all my kind of Zoom, WebEx, RTP audio, etc. I want to give these the highest priority. So these are put into the Platinum bucket. And then for my enterprise SaaS apps, so we use Google Docs here in Palo Alto. So all of my Google Docs, Gmail, etc. We have a bunch of AWS users. I want to give these the highest priority, or the second highest priority. So these applications are matched here in this gold bucket, and they're applied the gold priority. Then if we're going in priority order, then my enterprise traffic, so anything that doesn't match these applications but matches RFC 1918 will be applied silver. And then this default rule is going to be my internet traffic from my non-guest users, and I want to give this silver as well. The criteria was that the guest traffic should get the lowest priority, so that's been given the bronze priority group. Okay, so from a security perspective, I have a security policy that matches the criteria that we set out. So I allow traffic from my corporate LAN to the internet because my policy said I should fail over to DIA if my SD-WAN DCs are down for internet-bound traffic. My corporate LAN to WAN traffic, this is allowed from the source zone to the corporate WAN zone. This corporate WAN zone would include my Prisma SD-WAN VPNs and any MPLS underlay I have. My guest to internet is coming from the guest zone, which is applied to the same interface where the guest context is applied, is allowed only to the internet. And then corporate LAN to guest APs. So we had a use case where guest is not allowed to talk to corporate, but corporate must be able to manage the guest APs. So I have a rule in here that matches some specific services, and it's coming from the corporate LAN zone, and it's allowed to the guest zone, and it's matching from destination APs in a prefix filter, which are the guest LAN APs. So that means that traffic from this corporate LAN is allowed to access the guest network, but to only specific services matching specific APs. So there will be no traffic allowed from the guest to the corporate LAN. And then we have a rule here for inbound video camera app. So this is the use case where users need to access this server, and they're allowed to come in from the internet to the corporate LAN matching this server address. And then finally, we have a NAT rule, which is for the video camera web access. So we have a rule in here that matches a destination prefix, which is my public IP of the branch device. We have the destination port that it's trying to access and the protocol, and then the action is to do a DNAT. So this DNAT will be applied to a NAT pool that is applied to the egress interface or to the outbound interface for the internal IP of the server. And then quickly, we're just going to go to use case 2. So use case 2, a bit more complicated. We still have SD-WAN branches, we still have SD-WAN data centers, but in the middle of this, we have Prisma Access. So rather than sending our internet traffic DIA or to the SD-WAN data centers, we're going to send it to Prisma Access instead. So these are the business requirements. The site is onboarded to Prisma Access using the Cloud Blade, Prisma Access Cloud Blade, which is already done, and we're not going to run through that today. But enterprise users should still use their regional DC for enterprise traffic, but all internet-bound traffic, whether it's guest or corporate, should go to Prisma Access for inspection. If there are application SLA issues for the internet-bound traffic, enterprise users can go via SD-WAN DC as a backup, but guest users will go DIA. QoS is the same policy that we had before. For security, we have very similar requirements, but in this case, we have an IoT segment, and this IoT segment must be inspected by Prisma Access with no DIA fallback. We just head over to our policies. So if we look at our path policy here, so the guest traffic, this policy here is matching the context. Our paths in this case are standard VPN on public, which means a remote network to Prisma Access, but with fallback or backup to direct on public. And then for the service and DC groups, we have Prisma Access all regions, meaning that we can send to any of the Prisma Access regions that are configured. Our IoT apps, so this is matching the IoT context, and the paths here are standard VPN, meaning that we can only send this traffic to Prisma Access. It doesn't have any backup paths. If it's not working with Prisma Access, the IoT is not allowed. we have to inspect it. Then our service and DC groups for this traffic is Prisma access all regions. And then the default rule, which is all of our internet-bound traffic from the corporate users. This has parts of standard VPN on public, so to Prisma access, but backed up by the Prisma SD-WAN DC. And here in the DC groups, we have a standard VPN DC group, and we also have a Prisma SD-WAN DC group mixed together. So the primary DC group is for our Prisma access locations, and then the Prisma SD-WAN DC group is for their closest regional data center. And the enterprise default rule is the same as the last use case. The paths here are SD-WAN VPNs, and the service and DC groups are going to be their primary or backup DCs based on their geolocation. QS, these are the same policies that we used before, so we're not going to re-review it. And then from the security standpoint, we have same corporate LAN to internet, but in this case, corporate LAN is allowed to the corporate WAN, which is the SD-WAN VPNs, and Prisma access zone. The corporate LAN to WAN is the same, so we're going from corporate LAN and we're allowed to the WAN, which is the SD-WAN VPNs. The same guest management that we had in the previous case. And here we have the IoT use case, where IoT is from the IoT zone is only allowed to go to the Prisma access zone. So there is no fallback here. You know, we must inspect the IoT traffic. Guest to internet here from the guest source zone is allowed to the internet and Prisma zone. So Prisma is the primary, internet is the backup. There is no NAT for this use case. So I know we're kind of close to the wire, but that was all I had for you today. So I'm not sure if we have much time for questions, but thank you for everybody attending.